Well, my name is Caleb Smith. I'm here. I'm going to talk about Google Cast with you guys. Who here has worked with Google Cast before? Cool. Any iOS developers in the room? All right, nice. All right. Well, first I want to start with kind of a review of the platform and actually a celebration. So, happy birthday, Chromecast. 3 years ago this month, Chromecast was announced, and yeah, since then, it was kind of quiet for a while. And then in 2015, we saw Google Cast announce, and that was really where we saw the framework separated from the device that it actually runs on. Then later that year, we saw the Game Manager and Remote Display APIs released. It made things a lot easier for people using Unity. There's an NDK plugin too. And then in September that year, we got our second gen Chromecasts, which were beefed up. We got 5 gigahertz Wi-Fi with them. They actually have Bluetooth LE on them. And we also got an audio-only device. Later that year, the audio device got support for multi-room, which is pretty cool. And then more recently, we've had a bunch of announcements for speaker and TV partnerships. So now a lot of the devices you're buying in your normal entertainment outlet support Google Cast. All right, to start off, I want to go over a few terms before I start talking a bunch. You guys have no idea what I'm talking about. The first is senders. When I say sender, we're talking about the mobile devices or the browsers that the user is actually using to launch that cast session. And then we have receivers. These are the actual apps that are running on our cast devices. So we have our Chromecast, speakers, and TVs. Now, the framework as a whole to me can be split into 3 parts. First part is the discovery and connection. Like how does my phone find this device in my house that can support this application that I want to use? And then how do I connect to that? The next part is the actual transfer of messages back and forth, whether they're just custom message for a developer or something more. And then the framework has these APIs that are built on top of it for us developers to use for making some really cool apps. We've got the media framework, games, and again, remote display. Now these APIs are just built on top of this message transfer protocol, and we'll see that a bit later. For this talk, I'm primarily going to focus on the media side of things. It's the thing I've done the most, but there will actually be parts that relate to the game manager as well. All right. So starting with the UX, Google did a really good job from the start of trying to have a consistent user experience out there. And for all the apps that are out there, they all kind of function the same way. The icon shows up in a similar spot. You can kind of expect the same things as you're interacting with the platform. So that sets user expectations. Those are probably things, if you're going to make a media app, that you should pay attention to. They also publish these UX guidelines, which are handy for keeping in line with those expectations, and then also making sure you have all the components that a user is expecting to see. So it's UI components and the UX. All right, so for a media app, what are these pieces? So the first thing we have is kind of this introductory cling. So this is probably more important with some of the initial apps, but think of it yourself as a user, you open your app, and all of a sudden you have this new icon in the upper right corner. Like, what does that do? Why is it there? So you have this introductory clean and kind of explain what you're supposed to do with it. Another component is the mini controller at the bottom there, and that should be present anytime you're casting content and then have navigated away from it so you're somewhere else in the app. You've got these expanded controls, so if you click on that mini controller, this would open and it would give you some more options. So you can see like there's a forward and a backward and a couple other things. And then you've also got these dialog controls, which you would open from clicking on the cast icon. So lots of controls everywhere. Now you might think that's all we have to include, but nope. We also have this cast selection dialog, lock screen controls with a lock screen background image, and we also have this notification control that has to show up when we minimize the app. So that's a lot of stuff to add. So where should you start? Well, we can start from scratch and implement all that stuff ourselves, but let's not do that. That's a lot of work. A bunch of people have done that. Let's try to share code. The first attempt at this was the Cast Companion library. And then more recently at I/O, the new Cast SDK version 3 was announced. So Cast Companion library, some of the things that it gave us, has a large developer and app usage base. So there's a big benefit there. People have ran into bugs or fixed issues, and it's made its way back into the library, and you can benefit from that. It's now an officially supported library. When it first came out, it was just a sample. It takes care of a lot of the common boilerplate code for how do we scan for devices, how do we manage a session, all of that stuff. It also added some customization through like asset overriding, some styling. It was kind of limited, but over the past year, it's really gotten a lot better. One downside is it's Android only. So while we were living the nice life of having all this kind of out-of-the-box experience, iOS guys were having to do this all from scratch every project. And they have said that they're going to continue CCL, even though the Cast SDK version 3 was announced. So what do we get in version 3 of the SDK? Well, we get pretty much everything we had in CCL, except for the kind of baked-in expanded widget. It's Android and iOS. That's right. iOS developers, they'll get everything we had, reconnection logic. Not only that, the APIs are the same between the platforms. So when I start talking about a cast session or a cast context, the iOS developer is going to know the same thing and be able to talk the same lingo. It's part-of-play services, which is really nice. You get that level of release support, bug support, and kind of that normal update schedule. And it's really flexible. Every component that's in there that they use to build their widgets and everything like that is also meant for external developers to use and build off of. It's very customizable. All the widgets that are in there have themes. Each individual color for the cast icon, all that stuff is themable. Now, first thing to use this SDK is we've got to configure it. To do that, we have this cast options provider, which looks pretty complex, but the main thing that we need out of there is just that application ID. You get that after you register your app through the dev console. You'll just plug it in there. And then we have to add this entry into our manifest to let the framework know where this options provider is. So when it needs to configure it, it knows exactly where to find it. All right, next thing we can do is we can add the cast icon. So here we've got our main menu. And we're going to add this menu item in there. And the important part here is that it's got this media route action provider. Now, this is the same part of the support library that if you were trying to connect to a Bluetooth device, you would also implement this and give it this action provider. Then our activity, we've got this nice little factory that we can use, and we can set up media route button, give it the menu and the ID of the item, and that's it. You can launch your application, you'll have the cast icon up there, you can connect, you can have the same reconnection logic and all that. It's done. So what did we just do? Well, the main part there is we gave it the menu item that it needed. It grabbed the action provider from it, used this thing called a cast context, which we'll get into, and then got the route selector from the cast context and set it on the action provider. So, cast context. What is this thing? It's a singleton object, and it's lazily loaded, so anytime we need it and we request it with a context, it'll go look for the the options provider that we defined in our manifest, get our app ID from it, set everything up, and then we'll be able to go from there. It's the central point for accessing all of the version 3 SDK cast interface. So it's also got some pretty handy listeners off of it. One of them is this cast state listener. And so once you've registered that and set it up and initialized it, you'll get these callbacks to know, like, are you connected to a device? If you're not connected, that means there's devices around you, but you just haven't done anything with them. And then you can also know if there's no devices anywhere near you. So this is what that the menu, the cast icon, is actually using to know should it show itself or not. Then we also have this app visibility listener. This is mainly just so it knows when to show that notification up in the in the shade. But it could also be handy for some other things, right? So, I mean, anything else you need to know if your app entered the foreground or if it entered the background. So yeah, you just get the cast context from anywhere you need it, and you add the state listener or add the visibility listener. The cast context also has this session manager. That's all the stuff that you're going to need for that actual session, knowing, like, did you connect successfully? Was the connection lost? Were there any errors? Anything like that. It also has the cast session off of it, and that's the piece that we're really after. So cast session has all the application info that we need, so what's the status of it, what's the app name, anything like that. It also has all the device info, so what's this device's name, what does it support, anything like that. It also gives us access to the remote media client and then also access to that base messaging framework. So what we're mainly interested in is this remote media client. So in order to do anything with that, though, we're going to need to do some configuration back in our cast options provider. The first thing we're going to do is we're going to build out this notification options. And right here, we're going to set the actions that we want to support. You can support up to 5 actions in there. And they have kind of some baked-in ones like toggle playback, skip. You could add your own custom ones, but then you'll have to handle that a little bit differently later. You'll also see that we pass in this array with some integers. That's which actions do you want to show when that view's in its compat form, which is like the condensed form in the notification. You can also set the skip time, so anytime previous or rewind or skip is selected, that's how far it'll go. And then you can set the target activity that you want to be launched if that notification is clicked on. The next piece that we need to add are cast media options. And so the first thing we'll do is we'll set our notification options that we just created. And then we also need to add our expanded controller activity again. This is so for anything outside of the notification, like the mini controller or anything like that, that needs to launch our activity, can get access to it. There's also this media intent receiver. So this is what I was referring to before, that if you add a custom action to the notification, you can override this and actually receive that intent and do some processing with it. The thing you want to watch out for, though, is not all routes might go through your custom receiver. So if you need to do some special action before playing media and you register this, just be aware that not everywhere that in the app that you're trying to play media is actually going to go through this path, and that might be something you have to deal with. Last thing is we can set this image picker. Image picker is pretty cool because in the past, CCL and some other libraries kind of had trouble like figuring out what image it was supposed to show at what time. So they added this image picker that'll be called anytime the framework needs an image for some location, some widget that they provide, and it'll pass you the media metadata that we'll create here in a sec, and then a type. So you can go through there, look up what type it is, and provide the right image. All right. So we configure our media. What do they give us? We now have the hardware button controls for volume. We have image selection, so we can provide the right images for our backgrounds. We have a notification that should work anytime something's playing. And we have a lock screen background. All of that just by configuring that stuff in the cast options provider. It's pretty cool. All right, so let's create a media object so that we can cast it. First thing we're going to do is we're going to create this media metadata object. Right here, I've chosen just to provide it a type generic. There's some other built-in ones like movies, shows, and all that does is it's got a kind of a group of metadata fields that you can set on it and that other senders will be expecting for it. So in here, we're going to give it a title. We'll create some images, a thumbnail, and a background, and we'll go ahead and add those to the metadata. Now remember, the ordering is important because all your platforms that implemented that image picker are going to be expecting those images in the exact spot. Now, you might have some metadata that's more complicated than just one of those canned versions. So what you could do here is you can provide a metadata type of user, anything higher than that. So I think right now that value, that constant, is set at 100. Everything below that is reserved for the framework. So you can't override it, or if you do, they could get stomped on. So you're just going to go above that to be safe. Next thing we're gonna do, we're gonna add this title again. The only issue with this, though, is later we might go and we ask the remote media client to get the media that's playing. We're gonna go through the metadata, try to get the title, and then we're gonna see if we have a title. It's gonna be empty. Reason for that is the defined keys are reserved for the defined media types. So if you try to use any of the media metadata keys with a user media type or anything higher than that, they're not going to show up. You will see them on the receiver in the debug menu, but in your application and when you ask for it, you will not get it. Pretty frustrating. All right. Next part we're going to do is we need a content ID. Now, normally this is URL. It could also be just any identifier that the receiver can use to actually look up this media and figure out what it's supposed to play. And then we're going to use this media info builder, give it the ID, set a content type to be a good citizen, and we'll tell it the stream type, set our metadata, and build it. So this media info object is what I like to call a core object. What do I mean by core object? So it's broadcast to all senders. So even though you're at home and you're on your Wi-Fi, like it's not the most consistent network conditions. And so you can have senders coming and going, especially on the iOS side, like as soon as they have backgrounds and they come back, they need a status update. So as soon as they connect, they're gonna get any playing media broadcast to themselves. And so that media info object needs to have all the necessary information that they need to display the UI. So normally you'd have like your title that needs to display in the metadata, but you might have other stuff. Like if you're building a sports app, you might have some logos that you need to load based off of what teams are playing. All that stuff needs to be in there. So for the remote media client, that's their media info object. But for the game manager, that would be the game state, which is just a big JSON object that's broadcast to everyone. Well, how do you add this to it? So all your media info objects have this field for custom data. Custom data can just be some blob of JSON, whatever you need to fit into there. So to load that media, we're going to go ahead and get a remote media client from our cast session and load our media info. We could even load our media info, tell it if we want it to start, auto start or not, and we can give it a start position. So maybe they already watched 30 seconds into the clip, they can start there. Other thing we can do is there's another hook for some custom data. For a lot of the calls in the framework, you'll see this just JSON custom field that'll let you add whatever you need. All right, for updating the UI, first thing we need to do again is, or something you might try to do is get the remote media client, call pause, and then immediately show your pause UI. Don't do this. Remember, we were talking about the network maybe not being the most reliable. We don't actually know if the receiver received our pause command. So if you go ahead and do this, then now you're gonna, the state you're showing on the phone isn't gonna match what the TV's doing. Instead, what we want to add is this remote media client listener. And this is going to have a callback for when our status is updated. And it's also going to have a callback for when we send out a media request. That'll let us know like we need to show a spinner maybe. So we can go ahead and set that up. When our status is updated, we can see what status it is, and then actually update our UI. So now, yeah, we'd set our listener and then call pause. This is the hard way of updating your UI now. With the new SDK, we now have the UI media controller. So the UI media controller, you just go ahead and create it anywhere, passing it a context. It actually wraps the session manager listener and our remote media client listener, so all the callbacks that you would get from those, you can get from this single object, which is especially handy for our expanded controls, because that's all the stuff that it also needs. It absolutely introduces this cool paradigm for actually binding image views to different states of the cast session, or not necessarily image views, any views. So in this case, we're binding a view to whatever the current item is playing. So this could be our thumbnail. We could do it for a background, pretty much anything. We're also providing what type that is for the image picker. So they also let you bind the visibility of a view. So if the receiver's preloading the next item that's going to play, you can go ahead and show your up next layout. It's called after all the other listeners are called, so that's kind of nice in case you need to do something else. Maybe you don't necessarily want the UI to update until like the final state is there. The iOS developers that are here, I kind of blame the name for this on you guys. So, all right, custom messages. You want to avoid these for any media-related items. The media channel is really designed to handle these. So, for example, in a slideshow, you might think like, oh, I need to add like some next picture command and send that out. Well, you could still use the media channel and just use like the skip or next command like before, and that actually helps keep all the senders in sync. But if you do need a custom media channel, you can go ahead and register one like this. First, create the callback. You have to define your namespace. It needs to begin with that user namespace xcast part, and then whatever domain you want to give it so that you can get those messages. Set the callback, and good to go. This is actually the exact same thing the remote media client and the game manager are doing. You can see there at the bottom, the remote media client is just using that namespace for media stuff. And then it's sending all the play, pause, skip, everything over that message namespace. All right, so how would you store ads in a queue at the same time? So we do a similar thing where we go through and we create our ad media info. We can give it our metadata a different type of an ad just so we can identify it later. And go ahead and build that. Then we wrap those in these media queue items. So we'll have an ad item and a media item. And then we'll build our queue, which is an array of those items, and then call queue load with the items, which one to start with, and then the repeat mode that we want it to do. You can set up a queue so it just endlessly repeats, or you can have it off, or you can say repeat once, and some other ones. You'll also see the custom data there again. All right, so how do we tell that an ad is actually playing? So we'd have our client listener set up, and then on our metadata updated, we would get the media info for the current item, and we can check the media type, and if it's the type ad that we set up, we can go ahead and hide the seek bar or disable pause or whatever else we need to do. All right, some other things with ads. The receiver can also build this queue for you, so you can have that logic totally remote. You could send up the 5 videos that you actually want to play and have the receiver inject into the queue the ads in between. The receiver, again, just like with regular media, could actually go and retrieve those ad URLs, and it can listen for like ID3 tags in streams and actually fire like ad listener events. Another thing the receiver can do for you is adjust the playback rate. So when you ask for the current position of the media that's playing, if an ad's playing, maybe you don't want that time to advance. So the receiver can set the playback rate, and what that does is it's used as a multiplier. So it can say like, okay, 10 seconds have passed, and the playback rate could be set to 0, so it'll just cancel out, and it'll look like your current time is still, you're a minute into the video. Some authentication tips. Keep the senders authorizing the content, right? Like you've already built these intricate login flows, handled a bunch of use cases. Like keep that, the gatekeeper on the senders. Let the receiver do any kind of authentication you need to do. I know this can be hard because sometimes tokens only last for 30 seconds or something like that, but you should really try like, what is your average session length going to be? Try to make the token last as long as that. The receiver can send this along as cookies. You can add a custom header for it, or you could even add a query parameter that's got the token or some credentials in there. The auth token, the load commands custom data, is a really handy thing to use for passing that auth token. Analytics. First thing I would say is check out the dev console. They recently updated, and it's got a bunch of analytics in there that might be good enough for you. It's got the device and session count, average playback time. You can filter by like past 28 days, past 7 days, anything like that. It also breaks down what country and what device type the user had. Now, if that doesn't work for you or your client, then some things to consider are what kind of analytics are you trying to collect and where do they fit best. The sender is really good for stuff like, did it encounter a receiver ever? Different kind of interaction with the UI. It's not good for doing things like session length because, like I said with iOS, if you background it, your session just ended. You do have a token for it that you could restore, but it's a lot harder to keep track of. The receiver, though, is running for the entire session. So it's really good for like how many devices connected to me during that session, how many videos were played in that session, anything like that. It's definitely the best thing for media events. So play, pause, did the video actually end? That stuff you want to keep there. And SDKs. A lot of times you'll ask the analytics company if they have a Chromecast SDK. Your first response is going to be, no, they don't. Then you ask them, do they have an HTML5 or JavaScript SDK? And that's like, well, yeah, of course we do. Well, those SDKs probably run on the receiver, so it's always worth giving it a shot. Some other ones are like, I think it's Conviva. It hooks into media element events. The receiver is using the media element and pumping video data to it, so anything that does that, you can also use. Another thing you should do for your content that you're casting is kind of evaluate if it's good for it. Supported format is something you want to check. The content origin, where is this stuff hosted? Can the receiver actually play it? The biggest headache you'll run into a lot of times is trying to play a video and you get some error that the website can't load some JavaScript or some content from another domain. This stuff is left over from a long time ago where it was a very good security measure to keep websites from loading like malicious content from another domain or anything like that. So it's something you have to deal with when trying to load this content with their media player. The resolution that you're using. Is the orientation normalized? What I mean by that is if you're doing like a slideshow and so you want to show some video or some photos up on the receiver, oftentimes devices take those at a different rotation. And so if you don't normalize that beforehand, the receiver's got to know that and be able to flip it and adjust the rotation by actually like looking at the EXIF data, which is very hard to do on the receiver, and it's also kind of hard to do on the senders. So if you can do that beforehand with some sort of pre-processing and then cast it, it's always good. The other thing is use the demo apps. So you can actually get the Android or iOS demo app and swap out the URL to some of your content in there and cast it to their sample media player. Their sample receiver can play any of the content now that they support. So if it plays your stream, then you're good to go. All right, I'll talk a little bit about guest mode. So earlier I talked about the discovery and connection part. Usually that's on Wi-Fi, but now with the second generation stuff, we also have Bluetooth LE for the devices, and we also have, for Android for a while now, we've had these audio tokens that can be broadcast at a really high-pitched sound between the TV and your device and be used to actually connect to them without being on the Wi-Fi. There's also a fallback PIN authentication that you can use. When you're doing this, you'll notice you click the cast icon, the route will show up as a nearby device in there. And the other thing to keep in mind is, well, this is transparent to your app, so you don't have to do anything as a developer to get this support. The other thing to keep in mind, though, is that it does go through a cloud relay. So if you're hosting any local content, you won't be able to support with this. All right, audio devices. It's the same API as the remote media player. So if there's no reason not to support it, then you can just go into the dev console and opt in. On the senders, when you connect to a device, you can actually check if that device has a certain capabilities. And so in here, we can see we take the cast session, we get the cast device, and then we ask, like, does it have support for video out? Does it have support for audio out? And then one thing I noticed is pretty interesting is they actually have these video in and audio in now. So maybe they're planning ahead there. On the receiver side, you can also get the device capabilities for the receiver or the device you're running on. And again, you'll see kind of the same thing as Bluetooth supported, display supported, audio supported. Another thing you can do is when the request is made to load your receiver app, there will be this header in that request, and you can check that and see and actually like load two different receivers depending on if you're going to run on an audio device or if you're going to run on one with a display. All right, just some debugging tips. Even if you're not like a web developer or anything, the Chrome debugger is your friend. It's definitely going to be telling you exactly what's being broadcast to all your senders, and then you can see if you're actually seeing that in your app. They've made it really easy to get to it now. You just do Chrome inspect if you're on that network, and any of the devices on that network will show up. While you're inspecting, you can type in these logger level commands and set everything to debug so you can see what's going on. In the middle of the session, you could reload the whole page. You could pass true so it clears the cache in case there was a receiver update to make sure you're actually working with the newest device. Oftentimes, when I've seen the Chromecast reboot, like in the middle of testing something out, it's usually a memory issue. One thing with that is like if you're sending images for your slideshow and you're sending them at a very, very high resolution, Chromecast is only going to display those at 720p, so you don't need to send a giant picture to it. Another thing you can do is you can enable crash logs in the device settings for the Cast app. And then if you need access to those crash logs, you can reach out to Google and ask them for that. Some common problems with whitelisting. If you're unable to debug a device, when you go to Chrome inspect, like no apps show up, probably not whitelisted for it. What I mean by whitelisted, in the dev console, you actually have to register the serial number for devices that you want to be able to debug and work with your app. And then also, if you're hitting that cast icon and there's no devices showing in there, then chances are you're not whitelisted. All right, that's kind of all my tips. Are there any questions? If you're actually hosting local content, so like with the slideshow example, if you're actually serving those images up from your phone on a local HTTP server, then the receiver won't be able to get to that because that phone's not actually on the network. So all those messages are going out to some server and then coming back down through the Wi-Fi network to that device. So over your LTE or something. ExoPlayer, yeah, so we do, ExoPlayer runs on the sender device, but we have done an implementation where ExoPlayer on that device, and then you can cast, and you just get the URL from it and pass it up to the receiver. That is a good point, though. The receivers, a lot of times, companies will want you to use certain media players and stuff for the receiver app. Google actually provides a media player, and it's definitely one you should use, and they're very interested in getting people to use it. So if it doesn't support a certain media format or some sort of content protection, like they want to work towards supporting that. Before, the Cast Manager and the media player used to be separate pieces on the receiver. With the newer SDKs, they're actually kind of merging together, so you're kind of not going to have an option. A lot of times, the update process for the Cast Companion library can be pretty painful. And so if you find yourself in that situation, then it might be worth it to spend that time actually switching over. The other advantage is you have a lot more flexibility with the controls that you're doing there. So if you want better expanded controls or anything like that, then I would definitely say it's worth it. So for a while, all of the IDs and the mapping to their URLs were actually public, but they've since locked that down. But I guess if you knew how to look it up, but I don't. Good question. So the question was, if you had multiple senders connected to the same receiver, how would you manage a queue of these items? So the sender is adding or removing items in there. Well, so there's actually commands for inserting and removing, and you can give it specific indexes. And every time you do that, the queue is then rebroadcast out to all the senders. And so they should be able to get an updated version of it. And add or remove the items themselves. You still might run into some issues where they do it like at the exact same time. Then it's going to be probably whoever got there first kind of thing. So what receiver device do I develop? OK, so the question was, what receiver device do I develop against? I actually, at home, still use the first-gen device. It's the one that's closest to me and actually plugged into a monitor. But the Nexus players, since they're a receiver device, they're actually very friendly to work with, since it's the debugging's over USB instead of like through your browser. So it's much quicker, seems to be much more responsive and everything like that. So I would definitely recommend something that's actually plugged in over like ADB so that you can debug. Yeah. Cool. All right. Thanks, everyone.